So NCERT book back question, first question, a small candle of height 2.5 centimeter AB is placed 27 centimeter in front of the concave mirror. 27 centimeter, and this is the pole in front of the concave mirror of radius of curvature 36. The focal length is half of it, which is 2 ones are to 18 centimeter. Therefore, you know the focal length is somewhere here, and this is 18 centimeter. The object distance is which between F and C. Between F and C, you know that this is a mirror. It's going to get reflected, and form an image beyond C, which will be an enlarged image. So you can complete this diagram. Any ray parallel to the principal axis will pass through the principal focus. Any ray falling obliquely at P will also get reflected back obliquely in such a way that the angle of incidence is equal to angle of reflection. This is equal to theta, this is equal to theta. So thus you get your B dash A dash, which is your final image here. What is the question? At what distance from the mirror should a screen be placed in order to receive the sharp image? So 1 by F is equal to 1 by V plus 1 by U, mirror formula. The focal length is known, which is 1 by 18. It will be negative because the focal length is to the left of the mirror. So 1 by minus 18 is equal to 1 by V, and the object distance is also negative because it's to the left, minus 1 by 27. So therefore 1 by V therefore is minus 1 by 18 plus 1 by 27. So the LCM is 54. 18 3s are 54, 27 2s are minus 3 plus 2 is 1 by V. So minus 1 by 54. The V is equal to minus 54. It makes sense because you get the final image also to the left. The sum is over. So the second question is, if the candle is more closer to the mirror, the more closer and closer the object goes, the image will also recede back. Okay, but at F, the image will be at infinity. Between F and P, you will start getting a virtual enlarged image on the other side of the mirror. How would the screen have to be placed? You understood all these options. So then they are also asking the nature and the size of the image obtained here. Magnification is nothing but a Hi by Ho, which is also equal to, in the mirror it's V by U. Minus V by U in the mirror. For lens it's V by U. So you know that V is minus 54, so it will become plus 54. By U is negative, which is 18, which is also minus 18, and you get minus, what was it? U is not 18, I think U is 27, right? 27. So then you get minus 2. And that is the magnification, and it's negative. That obviously will be negative because this is an inverted image. Magnification is negative, shows that the image is inverted and real. The magnification is greater than 1 shows that it's enlarged, and magnification is positive shows that it is a virtual image, erect image. Okay, so M is less than 1 means diminished and all sorts of things. You understand that from 10 standard portion. So magnification is negative. So you know that the height of the image is minus 2 times the height of the object. And if you know the height of the object which is given in the question, was it given in the question? 2.5. Yes, it was given in the question as 2.5. So it's 5 centimeter, which of course is a minus sign, but the magnitude of it, if you're going to say the size of the image, will be plus 5 centimeter. So let's go to next question. The candle is moved closer and closer. You know, between F and P, you will start getting a virtual image on the other side, and the virtual images and cannot be taken on the screen. That's very important point. Real images can be obtained on the screen. The virtual images cannot be obtained on the screen. Cannot. Okay. So let's go to the next question. Second question. A 4.5 centimeter needle, which is AB, is placed 12 centimeter away from a convex mirror. The object distance is 12 centimeter. As minus 12 because obviously it's to the left side. This is the pole. The focal length is on the right side. The focal length is given to be 15 centimeter. It's positive focal length. Give the location of the image and the magnification. So it's common sense that this is a diverging mirror. So it's going to diverge and it's going to appear to come from some point. It's going to pass through the principal focus because it's parallel to the principal axis. Another ray is going to fall obliquely at P and get reflected back also obliquely, and it's going to appear to come from here. You get a diminished dotted line. Don't forget to put this in a dotted line. You get a diminished virtual image. Makes sense. Convex mirror is the rear view mirror which always produces a diminished virtual image, and so then that completes it. And what's the position and nature and everything you can answer. You can write 1 by f is equal to 1 by v plus 1 by u, and 1 by f, the focal length is plus 15, is equal to 1 by v, the object distance is negative, which is minus 1 by 12. Therefore 1 by v therefore is 1 by 15 plus 1 by 12, and so the LCM here is 60, and 15 4 is 60, 12 5 is 60, is 9 by 60 is 1 by v. So you can cancel it with the 3 tables. 20 by 3 is my answer, which is plus 6.67 centimeter, and the object obviously it's on the right side, that shows that image is positive, image distance is positive. So then next is magnification is nothing but hi by ho. It's for a mirror is minus v by u, and you know that the v is this distance, which is minus this is your v, right? 6.67. What is your u? Object distance is minus 12. Minus 12. So let's write that it's minus 6.67 by minus or minus plus, and object distance is, so what did I say? It's 12. Again, it's an inverted image. No, erect image, correct? Okay. So you know it's minus v by u, where v itself is plus 6.67, u itself is so plus 6.67, so it will be still negative only, and u will also be minus 12, and what can you say about this? Magnification is, have they given the height of they've given the height of the object, which is 4.5, and the focal length isn't described. What happens? Okay, so then magnification is hi by ho. Hi you don't know, but you know ho is height of the object, which is 4.5, is equal to minus v by u. You know this is the value, you can substitute it here. 6.67 by 12. So then therefore into 4.5 will give you your answer, which is whatever answer you get, whatever the answer you get, you can write it. So let's go to the next question. The next question is what happens is, as the needle is moved forward, whatever, irrespective of whatever position your object is, you are always going to get only a diminished image. Okay, so then as the needle is moved further from the mirror, the image shift towards the focus. Okay, so further from the mirror, it gets shifted. If you, as you move like this is also getting moved like that towards the focus, and goes on decreasing in size. You know, it goes on decreasing in size. Makes sense, right? So as you move towards the left, this is what happens. Okay, as you move closer and closer, it becomes enlarged and enlarged, and that's why you're seeing the rear view mirrors. As they come closer, they appear so big. Okay, so then that explains this thing. Let's go to third question. A tank is filled with water to height of 12.5 centimeter, full of water. The apparent depth of the needle lying at the bottom of the tank. There's a needle which is lying at the bottom of the tank, which you can call it as object. You know the light ray will go like this, and there will be a normal here, and it's going to move away from the normal, and it's going to appear to come from a point above, and this is where my image is. The apparent depth of the needle lying at the bottom of the tank is measured by microscope to be 9.4. Apparent depth is 9.4. The actual depth is 12.5. What is the refractive index? Refractive index is formula real depth by apparent depth. Real depth by apparent depth. What is the real depth? Is 12.5. What is the apparent depth? 9.4. So the answer is 1.33. The fact that it's 1.33 is nothing but 4 by 3, which is nothing but water's refractive index. That shows that it's definitely water. 1 3 ones are 3, 10 3 3. So then therefore this is nothing but water. We have memorized the refractive index of water. Now the next question is, by what distance with the microscope will have to be moved? So you have to move it through this distance. This is shift. They ask me shift. shift is it's nothing but 12.5 by 9.4. Shift is nothing but shift formula is, it's t into 1 minus 1 by mu also. Remember? Let me apply that. It's 12.5 into 1 minus 1 by 1.33. It's 12.5 into 1.33 minus 1 by 1.33, which is 12.5 into 0.33 by 1.33. Study something. So then what was I doing? So what will be the answer for this? That's according to me the shift is t into 1 minus 1 by mu. And if I apply that formula, are they even asking that question is what I don't know. We found it to be 1.33. Oh no, they didn't ask this question at all. I'm sorry. They ask it, then you know what you have to do. Or it but coming back to this question, they are replacing this water now. What is the refractive index of water? We found it. If the water is now replaced by liquid of refractive index 1 point, the whole thing is getting replaced by a refractive index of 1.63 up to the same height. But what distance will the microscope have to be moved? Oh, so then for the second condition, refractive index is equal to, it's given 1.63 is real depth by apparent depth. The real depth doesn't change whichever liquid it is. Real depth remains to be 12.5, but the apparent depth is going to change in this case. You can find what is the apparent depth. Apparent depth therefore is 12.5 by 1.63, and the answer for this is 7.7 centimeter approximately. Okay, once you get this, that's the real depth. You know the real depth and you know the apparent depth. You know the real depth and you know the apparent. Okay, but the thing is, you know the apparent depth of this object with the liquid. You know the apparent depth of the object with the apparent depth of the object, which was 9.4 with water. So you can subtract 9.4 and 7.7 to adjust the microscope from where it was to where it is now. So that's the question here. If you read the question and understand the question from the textbook, you'll understand what I've done. So let's go to fourth question. The fourth question shows that this is a glass and this is air, and you have a normal, and in this the light ray is entering from air to glass. It's falling at an angle of incidence of 60 degree, and it's from rarer medium into a denser medium, so it's bending towards a normal, and this angle they've given it to be 35 degree. Next, the light ray is actually entering from air, okay, and it's falling at an angle of incidence 60 degree, and it's entering into a denser medium such as water, and it's bending towards a normal, and this angle of incidence is 41 degree. Next is this case where there is water, and the angle of incidence at which this is falling is given to be 45 degree, and it's entering into glass, and it's going to bend towards a normal, and this angle is what they're asking. This is from water to glass. Okay, so then remember this, the first case is from air to glass, refractive index of glass with respect to air. And do you know the refractive index of glass with respect to air? If you don't know, you can also write sin I by sin R. If you know sin 60's value and sin 35's value, obviously in the exam they'll give it a sin 45. So then if you know these values, then you can obviously write those answers, which you can't do because in this they haven't given us the value. In that case, you'll get this answer to be refractive index of 1.5 probably is glass, and you know the answer. 1.5 always stands for glass. And let's take the second case.